My name is Sahana from AML department and my team members are Aishwarya, Preeti, Vijayalakshmi, Sahana RC. And today we are doing presentation on DL and LLM subject. Our topic name is implement and compare the performance of CNN versus LSTM for a sequence based data set. And these are the contents. Introduction. CNN versus LSTM for sentimental classification helps to identify emotions or opinions like positive or negative in test data. The MDM dataset provides real movie reviews labeled by sentiment. Deep learning model like CNN and LSTM can learn pattern and context in sequence. CNN captures local word pattern efficiently and while LSTM captures long-term dependencies and word order relationship. This project compares the CNN and LSTM performance for accurate sentiment classification. Problem statement. Sentiment analysis of texts like movie reviews is challenging due to language variation and context. Traditional model struggles with word order and meaning, so this project uses CNN and LSTM to accurately classify reviews as positive or negative. And next part will be continued by Aishwarya.
Thank you, Sahana. Here we are seeing about the handling variations in languages, which is used to review the language style, tones, and reviews, which is having a difficult models to implement accurately, and managing the long-term dependency contesting in a text sequence, which is used for overfitting the models due to the limited or imbalanced data, and we are selecting the hyper parameter tuning, which is used for the achieving optimal model performance, and last training efficiency, which is used to train minimizing the computation time for large data sets. And next is the safety risks. Misclassification risk. It is an incorrect sentiment prediction can lead to false insights placed outcomes for the wrong business or decisions, and the data privacy issues. It is having an improper handle which having the various sensitive and the personal information that can we can make the data private, and the model bias which having the imbalanced data training may cause unfair or inaccurate sentiment judges, and the over license AI which is mainly depending on the AI predictions without having the human verification can lead the misleading or incorrect hyper parameters, and which having the interpretations between the over license and the AI. The next slide will be continued by Preeti.
Issue. And next will be slide I will explain strategies data pre-processing. This involves the cleaning and normalizing text data to improve the quality of the input, which is turn helps increase the accuracy of the model. And next balanced data set, the prevent the model from from being based on toward a specific classes positive revenues techniques. And next sampling and use to ensure the even distribution of the data across all classes. And next model optimization, this involves the find this involves the find learning the model hyperparameter such as the learning rate, batch size, and the number of the layers to achieve the best performance. Next, regularization methods like dropout and early stopping are applied to prevent the model from overfitting, which is when the model performance well on the training data but poorly a new unseen data. Next, performance evaluation. The performance evaluation on the model CNN and LSTM is compared using the various metrics like accuracy, precision, and loss. The select the most effective model of the task. And next slide will be the framework. Framework. First one is dataset. The project use the IMDM movie revenue dataset, which is the collection of the movie revenue labeled are either positive or negative. Next, pre-processing. Specific steps include the breaking text into words after sequence normalization. Next, model use the project use the CNN and LSTM model. First one is CNN is to extract the local feature from the text such as important in grams. Next, LSTM means long term short memory used to capture long term uh, dependence and context within the text. Next, training and evaluation. The models are training using the TensorFlow framework as evaluating by comparing their performance and accuracy and loss matrix. Next is optimization, hyperparameter turning in the performance to further improve the model's performance and its ability to generalize the to new data. And next will continue by Vijay Lakshmi.
The conclusion explained by that both CNN and LSTM models works well for the sentiment analysis or IMDL movie reviews, but each has a different strengths. Capture the load word patterns quickly, and it is good for a short test because it focus on the near word relationship. LSTM capture the long term dependency and context, making it better for the longer reviews and deeper understanding. It also highlighting the data processing and hyperparameter tuning and regularization are important for the improving performance. Finally, it states that by combining both model strengths, we can build a more accurate and reliable sentiment analysis system. CNN is faster and better for the short test, and LSTM is understand the long-term meaning. Using both views, best sentiment analysis result. Thank you. Next part will continue by Sahana.
Thank you, Vijalakshmi. So I am continuing the code part. First we have to import required libraries. The code import necessary library such as a NumPy, TensorFlow, and a component from Keras to build and train deep learning models. And further we load and pre-process. It means we load the data and pre-process the data. IMBD dataset. Load the IMBD movie review dataset limited to top 10,000 most frequent word pads, all sequenced to maximum length of a 500 words of a uniform input shape. CNN model definition. Build CNN definition, a conventional neural network CNN with the embedding layer, Conway 1D layer to capture local pattern, global max pooling, dis- denser layer with the dropout, output layer with the sigmoid for a binary. And next we have LSTM model definition. LSTM model definition. Build LSTM. It means a long short term memory. It consists with the embedding layer, LSTM layer for a sequential context, dropout for a sequential context, sigmoid output for a binary classification. And next we will classify the model completion and a training function. Compile and a train. It means it compiles each model with the binary cross cross entropy loss and a Adam optimizer training for a 3 epoch using a batch size of a 128 and uses 20% of a training data validation. And next we have to train the CNN and LSTM model. Both models are built to train using definition function, progress and a validation result printed during training. Then we have to evaluate model on a test data. After testing, the both model are evaluated on a unseen tested data using evaluate function, which return loss and accuracy. Outputting final result, the script prints the test accuracy loss of a both CNN and LSTM model, allowing direct comparison for their performance. And further, we have the output. The output, it says that in a CNN model training, the CNN was trained for three epoch. After testing or unseen data, it achieved accuracy 86.20% and a loss 0.254 and in LSTM model, the LSTM model was also trained for three epoch. It is also trained for three epoch on the test set, and the accuracy is 87.05% and a loss 0.3111. So it by this we understood that both models are well performed, but LSTM slightly outperformed CNN in a both accuracy loss, meaning it made favor mistake and predicted better on a test data. Thank you.